Happy New Year and welcome to the channel. There is quite a number of YouTube videos regarding solving an equation of type x to the power of x to the power of something equals this something, and I decided to offer one of my own. Here x is raised to the power 2023 times, so you have 2023 x's and 1 pi in the left hand side. And the right hand side is just pi, where x is of course positive, otherwise the expression in the left hand side doesn't make sense, and you need to find the value of x. Remember that in a power tower without brackets, the topmost operation is performed the first. In this case, we first raise x to the power of pi, then keep moving down until we reach the bottom x and do the last exponentiation. As you've probably guessed, the number of exponentiations is not really essential, while instead of pi, actually I've already told you too much. Please pause the video and try to solve the problem on your own. Let s with index n be the result of n raising into power, n exponentiations. Of course, the value of s depends on x. However, we will assume x to be given and write just s sub n. All these s's form a sequence that can be assigned recursively. S sub 0 is just pi. No operations have been performed yet, while for n greater than 0, s sub n equals x to the power of s sub n minus 1. And we want s with index 2023 to be equal to pi. Let's point out the following. Point 1. All s's are positive. Indeed, pi is obviously a positive number. Then we raise positive x to the power of positive pi and get another positive number. And again we raised positive x to a positive power and get another positive number, and so on. Second point is maybe less obvious. X is more than 1. This is because if x doesn't exceed 1, while it still must be positive according to the condition, then we have s sub 2023 equals x to the power of s sub 2022. And since we assumed that x doesn't exceed 1, while the exponent according to point 1 is positive, the result will be not greater than 1, which makes it less than pi, while s sub 2023 must be equal to pi. This means that the exponential function f of t equals x to the power of t is monotonically increasing as a function of t. Using function f, the recursion equality can be rewritten as s sub n equals f of s sub n minus 1. And you have another chance to complete the solution on your own. Let's consider three cases. Case A, when x to the power of pi is more than pi. Note that pi is s sub 0 and x to the power of pi is s sub 1. So we can rewrite the inequality as s sub 1 is greater than s sub 0 and apply function f to it. Since function f is monotonically increasing, the inequality sign stays. But according to the recursion formula, f of s sub 1 is s sub 2 and f of s sub 0 is s sub 1. So we come to the inequality s sub 2 is greater than s sub 1. Then we apply function f to the new inequality and find out that s sub 3 is greater than s sub 2. And we continue this process to find out that each element of sequence S is greater than the previous one. So we can write a long inequality. Pi equals s sub 0 is less than s sub 1, which in turn is less than s sub 2, and so on up to s sub 2023. This means that s sub 2023 is greater than pi, but we want them to be equal. So we drop case A and consider case B, when x to the power of pi is less than pi. This time s sub 1 is less than s sub 0. And again we apply function f, and again the sign stays. Now s sub 2 is less than s sub 1, s sub 3 is less than s sub 2, and again we get a long inequality, this time with a different sign. However, the sign essentially doesn't make any difference. And case B is also unsuitable. The last case is case C. X to the power of pi equals pi. Now S1 is equal to S0, and all terms of the sequence are equal to each other. In particular, S sub 2023 equals pi, which is what we need. So the given equation holds if and only if x to the power of pi equals pi. By raising it into the power of 1 over pi, we find that x equals pi to the power of 1 over pi. And this is the answer to the problem. Of course, here the number of exponentiations can be any, and number pi can be replaced by any constant greater than 1. In this case, x is a to the power of 1 over a. In particular, for the equation x to the power of x to the power of 3 equals 3, featuring in several YouTube videos, the answer is 3 to the power of 1/3, or cube root of 3. What those videos forgot to mention is that the same answer will be for any number of exponentiations. And this is the end.